Hey guys, welcome to the third part of force body diagram. In this video, I'm going to introduce a machine called Atwood Machine, in which you can see two masses are hung using a string that goes over a pulley. Right? We have to make some assumptions here. The mass of the strings is massless, so we just ignore or we consider the mass of these strings are negligible, and we also assume the pulley is frictionless, right? So if you have to draw the force body diagram for two masses here, you have to draw the force body diagram for these two masses separately, right? And you can see they actually have the common string that just goes over this pulley, right? So the tension force of this string on this part of the string should be same as tension force for this part of the string, right? And you can clearly see the mass m1 looks a little bit heavier than mass m2. That's why you can see this object is moving downward, this object is moving upward. If mass of these two objects are same, doesn't matter where they are located, but they will be stationary. Okay, so in this case, to draw the force body diagram, you have to first figure out what are the forces acting on these two objects. So I'm going to start with mass 1. So obviously the force of gravity is acting downward. So we have two different masses. So I'll call this as mass of gravity 1 to indicate this is for mass 1. Okay. And the tension force, which is here, is acting upward, right? So this is for first mass. Similarly, for the second mass m2, the force of gravity is acting downward from here. And just to indicate this is for force of gravity for second mass, I will put 2, right? And tensor force is along the string is acting upward, right? So if you got Atwood machine and if you have to draw the force body diagram, you need to draw those two, you need to draw force body diagram for these two masses, right? And one more thing, just remember that as the mass of string is negligible and we don't have friction force here, the tension force on this side should be exactly same as the tension force on the other side, right? As long as the string is not extensible, means the string cannot be stretched, right? And it is taut, means like it is stretched properly, right? So to show the force body diagram for this one, what I'm going to do, I'm going to make two dots, one for mass 1 m1 and one for mass m2, right? So let me start with mass m1. So this is the mass m1. Force of gravity is acting downward. Okay, so F G, I'll put 1 because this is for that is equal to m1 G. All right, and you can see if you look at these things carefully, the arrow indicates the m2 is going upward whereas m1 is going downward, but the tension force for both this side of the string is same. That means if the net force, if the mass m1 is moving downward, that means net force is acting downward. Because of that, this mass m1 will go downward, mass m2 will go upward. So the tension force that is acting in the opposite direction of this one should be slightly smaller than Fg. Okay, that's Ft, right? Or you can simply call tension force that's indicated here, right? And I already said the examples that you have seen before, because the mass was hung, it wasn't moving. That's why the tension force was equal to force of gravity. In this case, M1 is moving downward. That means the force of gravity must be more than tension force. As a result, the net force is acting downward, right? Now I'm going to draw force body diagram for M2. So for force body diagram for M2, again, I'm going to make another dot. This is just to indicate this is for mass 2. All right, I should actually have written mass 1 here. And the gravity is acting downward. All right, so force of gravity for M2 is mass 2 times g. That's equals to, all right? And as you see, this arrow indicates the mass m2 is moving up. The tension force must be more than the gravity force here, right? So the tensile force must be more than the gravity force, all right? And as you'll be allowed to use the ruler, right? Just make sure that the tensile force here is same as tensile force here, because the magnitude of the tensile force on either side of this string should be same, right? So this is the case slightly different than the case that we before, where mass was hung on a string and mass was stationary. But this time, both of these masses are actually moving. That's why it has got some value for the overall net force. For M1, the net force is acting downward. That's why we can conclude the gravity force is more than tensile force. Whereas M2 is moving upward, that means the tension force must be bigger than gravity force. That's why the net force is acting upward for M2. Although the tension force on either side of the string, which is Ft for M2 as well as that for M1, should be same.